Someone has printed handouts. Guide. You have raised your hand. You have read down queries. Uma means by mistake. Okay. Proceedings proceedings అన్నాను FDP proceedings అన్నాను అంటే proceedings అంటే ప్రొసీడింగ్స్ వస్తాయి ఆయన ఏమన్నా that was okay, intelligence here okay. Suddenly information went on international global proceeding other companies NASA website వాట్సాప్ చేశాను meanings and last మేడం దీపికే పంపించారా మీరు వాట్సాప్ లో చేశారా మీరు క్లోజ్ చేస్తున్నాను దాన్ని ఫుల్ చేస్తాను.
Hello, am I audible? Please confirm.
Yes, sir. Yes, sir. We are audible. Welcome, sir. Damodar, sir, welcome.
Hello, madam. Am I audible? Please.
Yes, sir. We are audible. Actually, to the presenter mode. So after introduction, you can share your screen, sir. Jyoti, start.
Okay, ma'am. A very good afternoon to one and all. Welcome to 8th day of Faculty Development Program on Emerging Research Trends in Computer Science and Engineering. Myself, Rednam SS Jyoti, working as an Assistant Professor in the Department of Information Technology in JNDA GV Vijayanagaram. It is my distinct pleasure to introduce our esteemed resource person, Dr. Damodar Reddy Edla, NIT Goa, for today's FDP on emerging research trends in computer science and engineering. Dr. Damodar Reddy Edla is presently working as an associate professor in the Department of Computer Science and Engineering and Dean at National Institute of Technology, Goa. He received MSc degree from University of Hyderabad in 2006, MTech and PhD degree in Computer Science and Engineering from Indian School of Mines, Dhanbad in 2009 and 2013 respectively. His research interests include wireless sensor networks, cognitive neuroscience, brain-computer interface, and medical imaging. He has published more than 200 research articles in reputed international journals and standard conferences. The publications include reputed journals such as ACM Transactions, IEEE Transactions, IET, Elsewhere, Springer, Taylor, and Francis and Wheeler, etc. Dr. Reddy has 6 granted patents in brain-computer interface and sensors. He is senior member of IEEE, ACM, and IAC SIT, and also received several awards such as Young Faculty Award, DKIF Best Researcher Award, Asia Arab Distinguished Faculty Award, CSIR Senior Research Fellowship, Dr. APJ Abdul Kalam Lifetime Achievement National Award, INSA Visiting Scientist, IEEE TIM Outstanding Editor, IEI Chartered Engineer, etc. He is also editorial board member of several international journals. He has also published 5 books by reputed publishers such as CRC Press, Taylor, and Francis, etc. He has handled various administrative positions such as Dean, Students Welfare, Head of CSE Department, Training and Placement Officer, First Appellate Authority, Senate member, AAC member, member of Board of Governors, Chairman, NEP Cell, Chairman, PhD Admissions, etc. at NIT Goa. Also, Dr. Reddy served as a nodal officer to the search committee for the recruitment of Vice Chancellor of Gondwana University, Maharashtra, chaired by the Honorable Retired Chief Justice of the Supreme Court of India, Sri R.M. Lodha. Further, Dr. Reddy is a member of Goa IT Advisory Council chaired by the Honorable Chief Minister of Goa. Dr. Reddy delivered guest lectures and keynote talks in more than 250 engineering institutes and universities across the country. 9 of his PhD scholars have been awarded doctorates. Another 14 PhDs are ongoing. Dr. Reddy has examined more than 50 PhD theses and he is the Board of Studies member and Academic Council member of various colleges and institutions. Dr. Reddy was invited as a visiting researcher at St. Mary's University, Canada, visiting scientist at Ulster University, Europe, visiting professor at University of Southampton, UK, and visiting research consultant at AI Tech, Leeds, UK. Further, Dr. Reddy also has 6 sanctioned research projects of worth more than 4 crores. To the best of his achievements, Dr. Damodar Reddy Edla was enlisted in the world ranking of top 2% scientists 2023, released by Stanford University. Now I express gratitude and invite the today's resource person, Dr. Damodar Reddy Edla, NIT Goa, to our faculty development program. I'm truly honored to have Dr. Damodar Reddy Edla with us today, and I sincerely appreciate his willingness to share his expertise. Without further ado, please join me in giving a warm welcome to Dr. Damodar Reddy Edla. Welcome, sir, our today's faculty development program.
Yes. Thank you,
Thank
madam.
you, sir,
Thank you.
for giving me this opportunity.
Yes.
Over to you, sir.
Yes. Can you hear me? Please confirm, madam.
Yes, sir.
Sir, we can hear you.
Yes. Thanks. Thanks for the introduction, and I'm sharing the presentation slides. Let me know once it is shared.
We are able to see your screens, sir, virtual augmented challenges and applications.
Yes, thank you, madam. And so to begin with, this session we are going to talk about the concept of virtual and augmented reality and the real-time actually motivation of this particular domain, and then what are the state-of-the-art challenges and various applications in multidisciplinary manner, and eventually, if time permits, some case studies we'll see. Now, to begin with, when it comes to the concept of virtual and augmented reality, let us start with the more often word, which is the virtual reality. What is the emerging need of such a particular technology, uh, where we try to make such a graphical illusion to the users who are experiencing such highly graphical experience. If you particularly look into the scenario before and after pandemic, the emerging need of virtual and augmented reality, how it has grown over the years, particularly last 2 to 3 years beyond pandemic. Many of you are already doing, knowing about this concept of virtual and augmented reality. Before we look into the basic definitions and the challenges, tell me what is the real-time need of making such a virtual illusion or an impression to the user who is going to who wants to experience such a technology, which actually make an illusion or an illusion to the human users, such that an impression is made that as if like it happens in front of your eyes. So the basic reason for it, there are certain applications, there are certain problems where we need this particular technology, where I can replace the concept of white to a certain particular physical nature which appears in front of your eyes. If you look into the challenges we have faced during pandemic time, there are plenty we have seen in terms of limited facilities, medical healthcare technology, or you can say in terms of limited facilities we have, because we rarely use Google Meet or any other online platforms before the pandemic. Rarely we use even for some online presentations and all, because when the frequent case of requirement. When it comes to the case of now, if you see everything, the first option is online. If not, we go for offline. So, what is the real-time need of that? When we look into, then the phase of virtual and augmented reality is on the other side. It's a beyond comfort. Now, when say there is something cannot be done offline, I need to have something online, and something can be done in online. Why can't be done in a better way? Are you understanding? When we say virtual and augmented reality, just don't try to consider it as a replacement for offline and call it as an online feature. That's not just an online feature, right? Are you following me?
Sir.
Yes. So when it comes to the concept of virtual and augmented reality, we are not going to just call it as a technology that replaces something physical to a virtual concept. No, beyond that, the way we experience those graphical illusions are highly graphical nature of the scenes and scenarios, and we give an impression to the user. That's not an easy technology. Thereby, it has attracted and billion dollar market is being foreseen by many researchers in the world, and that's why the research in this particular domain has become now in very attractive. So when it comes to the applications, when I look into like I need to make some certain virtual reality system or a technology. I will give a simple example. I think in Germany or some country there was this there was a small baby who unfortunately passed away. Then what happens? The parents are babysitting that baby a lot, and for years they could not see her. And incidentally, there is a startup company named after some concept of virtual reality. Then they have come up with a proposal that whomever you are lost, we can bring back in the virtual world. Means I can create some graphical illusion such that you can experience, you can feel that the person who died, who is no more, can come and speak to you in front of you. So similar way they have used, and the baby who passed away, the parents could be able to speak to her. And of course, sometimes even when we have highly, high-end hardware technology exists in this domain, you may feel the sense of touch also. Who knows? So eventually, on the other side of this technology, when we look into it, is not just creating some graphical interface or graphical experience to the user who is using this particular technology. In the process of creating such an experience to the user who is adopting or who is using the technology, we have a lot of challenges, not only software, not only hardware, the communication related and interface related. And technology, real-time system that must be a real-time system, even if being planning use, online education use. And when we had a lot of problems in migrating from offline education to online education, there are a lot of, people who could not, transfer. And obviously, when we come to an online education, that's not really so challenging. But at the same time, the experience that the students can feel, it's not so unique like we have in offline mode, right? Thereby, people started like, can we have a virtual reality system that replaces the teacher, or you can say that exactly, gives the impression like the teacher is speaking in front of me and teaching me, where I'm learning. Even the student faculty also can feel that the students are sitting in front of him. Now, when we come to such a level of technology where it replaces the actual thing with a virtual thing, try to understand. Definitely, there is a case where we fail to differentiate these two, which is real, which is not. But at the same time, it has a lot of advantages, many things which we can do at fingertips. Can you imagine a doctor performing a surgery from a remote location on a patient who is far away from him? A teacher teaching a group of students who are miles away from him. And similarly, uh, an e-commerce application who is trying to sell some products, the users can, use them in a virtual world and experience, and then only they can place the order. So there are plenty of such an options or features come out of this particular domain. Thereby, people started, thinking very crazy about this domain. It's not only watching some 3D movie or some graphical experience to the users. Beyond that, beyond that. Therefore, the concept of this particular technology has become unique, and $1 billion market is now in front of us. Now, before we formally define or just see what exactly the definition of virtual and augmented reality, let me know if you have any doubts. The actual motivation and application side, I don't think, because already we have talked about a couple of applications. Uh, any doubts? Please be interactive. Feel free to stop in case you want to ask something.
Yes, sir. If they raise their hands, then I can unmute them if they are having any type of clarification. That's why.
If anybody has doubt, no, madam, please unmute them. I think, right? Yes. Now, when we define the concept of virtual technology, virtual reality, and augmented reality, eventually, like our expectation would be different in nature. Like when we say we could not remain satisfied from just a black and white mobile. Just a grayscale. Screen when we look into. Then we started color phones. When we say for a better display purposes. Then smartphones. Then iPads. Then laptops, high-end laptops, notebooks, netbooks. Now I think Apple and other they're going to come up with a different way of virtual reality technologies where you can imagine everything in front of your eyes. So if you can understand, there is a clear distinction or difference between these two when we look into. Assume that I'm just making a video call to my friend. Is it virtual reality technology? Somebody just let me know. If I'm making a video call in my smartphone, is it a virtual reality technology that I'm using here? Because when we say the underlying definition of virtual and augmented reality, there is a slight difference. In virtual reality, there is a closed, goggle or a headset that we are going to, VR headset or a VR device which we are going to use, where inside the device the user is, lying around, and then only whatever the experience, the highly graphical nature of the scenes and scene generation, visualization, all those things, we are going to see in a closed environment. At the same time, when we come out of that particular device, or you can say the experience, we feel alive. But whatever, as long as we are inside that particular illusion, we are going to experience the high-end nature of this particular graphics completely in a different way. When it comes to the concept of augmented reality, you're not fully confined in a particular closed region like that. Same time, you also have some interaction with the real-time world, like a smartphone which you are using on your phone. On your this one. So, how a smartphone can be used for some particular communication, video, audio communication, various other modes of interfacing. Definitely, that is also a concept of virtual reality. But how it has different, how it has become different over the time, because when virtual reality was introduced, there was no concept of augmented reality. Are you following me? When there was introduction of virtual reality, it was not parallelly defined what is augmented reality. Because we are going far and far away from physical experience, actual experience, to the virtual experiences. Then people started, I mean, uh, defining how far it is good, the technology of virtual and augmented reality, how far I can reach. Then people say, like, if there is a limited, or you can say whether it is fully immersive or not fully immersive, the type of graphical experience you are seeing. Based on that, people started calling it as like virtual reality technology and augmented reality technology. The second one, we have communication with the real-time world or internet or any Bluetooth or any other way of communication. Same time, you are not inside a closed region of some graphical experience where you are under, you are not able to differentiate which is real, which is not. Right? Having said this, when we say virtual reality technology is very, very, high end, or you can say very, very uh, advanced, we should not be able to identify the difference between the truth and the illusion. Therefore, it is very important how such a complex hardware technology, same time the software tools or the software concepts we are going to develop, such that such that we will be able to address all those high-end applications like online teaching, e-commerce application using some recommendation system. If I can choose a particular object to buy or a good to buy in an e-commerce application, the same time it gives a recommendation system to me. You can try all these other products, and it can give a particular 3D graphical experience to you. In case you use this particular goods, your appearance would be like this, like this, like this. So it is like virtual reality for e-commerce application along with recommendation systems. You see the combination, how it is good. Obviously, we need machine learning eventually, and somewhere you also require IoT concepts, right? Now, when it comes to augmented reality, do we really require augmented reality? Yes, because adopting to such a virtual reality technology all the time in a closed environment, that's not possible. Therefore, you require a relaxation. That's called your augmented reality when you look at it, because you often need to communicate, interface, interact. Cannot always remain in a closed environment like that. We cannot use it. Heavy text reading purposes, you cannot use virtual reality technology, right? So to address with all this concept, there is another side of the technology which we have brought it, augmented reality. That's that's the concept as it is. So any doubts so far before we see the type and nature of this both, and then also see the various application? Any doubts so far?
Please proceed.
Okay. So now the basic difference between, as I mentioned, there was no augmented concept in the beginning when it comes to the concept of virtual reality. When people started identifying certain challenges which we cannot, address in the concept of virtual reality, then started imagining a slightly a different version of the virtual reality concept. Because not every application we require, the highly theoretical graphic experiences. Do you agree with me? Yes, right? I don't require every time some 3D image to, 3D video analysis to work. All that's not required. So obviously what happens, there are some cases where we require a minimal interaction. Full immersion we may not require to make such a graphical experience to the user. So obviously, then people started just compromising with the experience that, the graphical scene, a graphical experience that are given to the user. Same time, add some more features by way of interacting with the user coming from, outside world. Therefore, that's why augmented reality when we consider as a like mixture of your real virtual world. Where in case virtual reality, you are entirely confronted in a closed environment, right? Similarly, how people interact in case of augmented reality and virtual reality, either sides. Here people they want to interact much over some internet network or some LAN area network or a wide area network or some Bluetooth medium, whatever it is, some connectivity. Same time, the type of hardware devices we use is difficult. And when in case of this virtual reality, as if we, when you are watching a particular graphical scenario, it is very difficult for you to understand what is the main, what is actually real, what is not. In a similar way, the type of hardware we require. Normally, we call it as a smartphone or any other smart electronic device, an iPad. That serves us to see the effect of augmented reality. When it comes to virtual reality, the sophisticated, dedicated hardware setup required to see and experience the highly graphical nature of the scenes. Now, just we start with the concept of virtual reality, and then the basic characteristic, as I mentioned, when we talk about big data, we have like VQ and becomes V4. Either way, we have here I3, IQ. When we talk about the characteristics of virtual reality, we have immersion, interaction, and imagination. If you observe these three, the concept of these characteristics, how an immersion effect being made in the hardware infrastructure that we are making, and same time how we are trying to interact or make an interface in the system. That's also very important to understand. Same time, how the things are going to be imagined and then going to see the next level here. Because at various phases of this particular, at various levels of this virtual reality uh, technology, eventually we need to understand these three concepts. How a graphical experience is being created, how communication or interaction can be made, and how certain imagination of the objects and then real-time changes can be made in the scenario which you are trying to make or so all those things, these three characteristics are very, very important to understand the virtual reality. So it's called the VR triangle. Now, when you compare virtual and augmented reality, virtual reality when we look into uh, and augmented reality with these basic characteristics like how the scenes are generated, what type of display device we use, what type of is immersive or not, and then how tracking is being performed here, all those things. So in case of virtual reality, as we already talked about this, it is going to replace the entire, uh, scenario to be highly graphical in nature, and the real part, the the realistic scenario is being completely drastically changed to a virtual scenario. So obviously we require the realistic images here because we are trying to create or make or produce the graphical experience to the user based on the realistic scenarios or images. So for scene generation, we normally require realistic images. If you want to create normally, not like that for every scene generation, you require realistic images. May not be some, maybe graphical images. That's fine. But mostly you require realistic images for most of the scenes. When it comes to augmented reality, you may not require a lot of realistic images. Some rendering is okay. It tries to consider because the way we give the communication to the user, the way we have the experiences, graphical experience to the user are different in case of augmented reality as compared to virtual reality. The hardware requirements, how about the display type, etc., etc. The display device, normally it's fully immersive, highly graphical in nature. And obviously, because we are in closed synthetic environment, we require some large view, lens. So obviously, there should be wide field of view. So a wide field of view device with fully immersive technology is needed in order to give an experience to the user of such a graphical nature. When it comes to augmented reality, it's not fully immersive like because it's not like a closed environment you're going to experience those graphical nature. It's obviously non-immersive. And same time, the field of view is the lens size also may be less, may not be very big. When it comes to tracking, how are you going to track certain objects and features, etc., etc. When you try to make some scene generation, or how you're going to, replace the reality in virtual reality. Some low to medium accuracy we try to achieve, and the rest of the part the graphical interface can take care. And when it comes to the augmented reality, normally we require the highest accuracy because, as if like we have seen, virtual reality based on the realistic images we are trying to capture. In augmented reality, some rendering is permitted. So obviously, the highest accuracy we try to expect in case of augmented reality. So these three, four basic characteristics one has to achieve when we try to talk about the, concept of virtual and augmented reality, and then how we are going to address those concepts. When it comes to reality versus virtual reality, how a realistic image, if I mention how a particular scene generation is going to happen in a virtual reality device based on realistic images. So when you give a realistic images, how that realistic images is going to be a virtual, reality experiences that is going to be given to the user. So normally in a realistic world, when we talk about, we have certain actions. There is, certain, tasks or some particular object. Based on the realistic objects, based on the realistic entities, we create certain senses. Or certain senses will be identified, which gives certain consciousness. Then desired actions will be performed and the reality will be observed by the people. Just when it comes to a realistic scenario. Now, virtual reality, when it comes to between these two, before senses, we have output devices, and after actions, we have input devices. Now, these two devices, they try to make interface and then convert such realistic images to generate certain scenes that are given to the users for experience. So normally, as I mentioned, in this VR system, there are input and output devices. As I mentioned already, how sensing happens, consciousness happens, because when you talk about the central nervous system and the motor sensory organs, when you look at how the communication happens. Similarly, in the VR system, we have normally input and output devices. When we talk about the human perception and actions, this is my perception, this is my action. Between these two, I'm going to have these output and input devices of the virtual reality technology that gives my particular experience. Now, selection and manipulation techniques we use. Any doubts so far?
No one raised their hands, sir. Except that they don't have any. Well,
Yes. Right. Now, when it comes to the concept, as I mentioned, how a realistic scenario can be converted to, transformed, we say, that's the transformation we try to make it. How better, how effectively the transformation is going to be seen. Accordingly, we call to the, the accuracy, or you can say the best, VR experience we are trying to create, not design, create. So when it comes to such a particular technology, and obviously we need to perform various operations in each and every part of this particular in generation, or you can say the frame by frame learning of this particular virtual reality experience in closed environment. We obviously require selection operations, manipulation operations. In selection, when we try to talk about certain objects, the indication of object indication is very, very challenging. Because when you try to explore for a specific scene generation, and the specific features or specific tasks to be identified, the corresponding objects to be identified. To identify the objects, and we need to confirm the selection of those objects or certain regions, certain features, and then some feedback mechanism will obviously be there. So selection setting comprises of these three: object indication, confirmation of selection, and feedback. And in the object indication, we have occlusion and how a particular object is going to be identified, how can I touch an object and how the sense of it can be seen, and how it can be identified by the system to understand and go to the next level or next phase or next scenario. Similarly, pointing 2D or 3D, etc., other level of 3D. And selection, indirect selection. We are going to see a particular region selected such that a particular component will be identified. Mostly it's easy to understand these particular challenges or operations in the gameplay. And similarly, manipulation. In virtuality manipulation techniques, we have exocentric and egocentric metaphors, either metaphor. Now, in these two, when you look into in exocentric and egocentric, we have a lot of other complex operations we try to perform: word in word and automatic scaling, and virtual hand metaphors, virtual pointer metaphors. It depends on, don't think that for every virtual technology we need all of these operations. No, it depends on for which specific application I'm going to address these, or I mean how I'm going to address. Accordingly, these operations can be applied. The selection operation is one crucial operation. In manipulation is more challenging at the same time. Now, before we see that, now, can you tell me some of the, all of you who are following, just give me some applications where I can use virtual reality technology, some applications where I'm not comfortable to use the concept of virtual reality. Somebody please tell me, I'll see the chat box and get somebody to post. Anybody? Just after all these applications, can you just talk about quite a few applications which you can understand so easily?
Yes, Aruna, you are unmuted.
Yes, please tell me.
Aruna, you are unmuted.
Now can you hear me, sir?
Yes, I can hear. Please.
Yeah, we can use it in the medical sector, sir, like for virtual surgery as well as doing a practice surgery before conducting the actual complicated surgeries. And also we can use it in advanced scaling areas and when we are dealing with few people who are having certain diseases where, their fine motor skills are being affected, they also use this to an
Yes,
extent.
so many applications you talked about, all of them are, I think, meaningful. And particularly when we say, just a simple example, when we say in healthcare, domain, when you look into, obviously we talked about an application where a doctor from a remote location can perform surgery, but they require the concept of robotics, they require the concept of IoT, they require the concept of virtual reality, they require the concept of computer vision related. So, but that's very high in nature, but that is quite possible. You need to have effective communication and an interface. Please understand that these two are different. A solid or high-end communication and high-end interface with a reliable communication with no latency. Because when you perform these operations for a remote location of a doctor, a high-trained robotic prosthetic or maybe a robotic device to perform the action on real time based on the signals from the doctor who is located at in a remote location. So that's quite possible. But beyond that, I would also suggest like diagnosis system. We can also propose a diagnosis systems where you see we have experienced certain challenges during pandemic time. Doctors are not all, but some of the doctors are hesitant to have physical contact because that's very justified because now cases like this, the corona and all, we don't expect doctors spend to have physical contact with patient every time because they also take care of the uh, safety of the doctor's center. So if you can come up with a diagnosis system, of course, may not be fully for all type of diagnosis tests, it may not perform, but at least the contactless diagnosis where when a doctor located, in a remote location, he can wear a robotic arm type glove where he can touch an object there where he can feel the touch of the patient, but patient is not actually there. So it's as if like the sense of the patient, sense of the touch of the patient can be experienced by the doctor, though he's not actually touching, he's touching some other hardware object here. So something like that. And but problem is there should not be any feature loss here. When you touch the object exactly, it should give the clear impression that he is touching the patient to some diagnosis level. So that is one way of see diagnosis and treatment. They're completely different. And either way, online teaching methods and similar way. I think one more also, I think some phobias. I think it maybe you highlighted. Somebody who has a spider phobia. So we can say make certain demos on spiders, and in a closed environment we can train the subject because he has some courage that because he knows that it is not a spider, but he's getting trained now. So it is like a supervisor learning. So he's getting in the particular demo of spider so that he can get rid of the spider phobia. So all these applications, plenty of them. Now I also asked another question. Can you also tell me some applications where virtual reality may not be suitable? I think again Aruna has some doubt. I think Aruna madam and then somebody, yes, guy. So please let me know your doubts. Are you unmuted now? I think Gayatri. Yes, Gayatri, please.
Gayatri.
I think you're unmuted now. I think you raise your hand. Okay. Anybody else? Aruna? Still it is raised hand. Any more doubts? Somebody? Anybody else?
I think no doubt.
Yes. So now when it comes to the, I'm going back to the big picture. Yeah. When it comes to the concept of virtual reality, it may not be really needed for certain applications where heavy reading or text editing is involved, and particularly many non-visual elements, because this particular technology is meant for visual experiences. So eventually, for non-visual elements domain, this particular technology may not be so effective. You can always do that, but not very effective experience that is going to be seen by the users. And the technologies often need the connection or interaction with the real-time world, and also some case studies or applications where we require some haptic and also feedback mechanisms. But those needs may not be very effective. Whereas systems or problems where we have lot those things, it can be one of the best solutions. So how, I mean, an effective case study or an effective VR system can be designed, and what are the major, I mean, devices to be used. Uh, so when we try to stimulate certain scenes in the virtual reality technology, we have to understand how we take the output and how we simulate it into a real scene. See, take a particular real scenarios or scenes, real-time images. Then we try to make an interface and then try to create some scenarios or some graphical experiences. So how do we simulate the real scene? That is very, very important to understand. Same time, how do we map those output to devices? That's also very, very important. Because the graphics, scenes to graphics to HMD. That is also very, very important to understand. Then after that, we need to use the devices to stimulate those scenes. Again, scenes to what this HMD type stimulation. I think. So obviously, when we try to make such a complex transformations output, I mean, such this integrations, eventually we require a lot of technologies, how visual simulation is performed, how 3D graphics integration can be done, how HMD can be generated. Then finally, how the vision system can be interfaced, where we have a human-machine interface model to be seen. Then finally, we are going to give an impression to the brain, which is going to see the illusion experience based on all this visual simulation, 3D graphics, and HMD. All those. So it's very, very important how we are going to make such an interface such that these particular objectives are satisfied. Any doubts? Okay. So how we are going to stimulate the scenes basically visual stimulation to 3D graphics to HMD. Okay, this the role of 3D graphics and to HMD is very important. Head mounted display. When we talk about HMD, this head mounted display, how we are going to give a vision system based on human machine interface. So eventually, once the HMD is ready, we are going to have the vision system, right? That interface to the human brain. That's all. So it's very important, the challenges. In this process, obviously, we are going to use the human, the sensory neurons, I mean, this like auditory, visionary, haptic, and the speech type, other type. Then the human machine interface, how we are going to have, if it is the devices like some drivers, we are going to have the 3D sound generation drivers, and uh, and similarly some robotic arm type and some tracking type, hand gloves, etc. etc. Now the concept of tracking in virtual reality, that is also very challenging when we try to understand how we have the need for tracking, because see, assume it's just a game playing application using virtual reality. I'm going to be part of the game as a user requirement, and I'm going to use a virtual reality device or a head mounted display. Using that and using some particular connection controls, I'm going to see how this particular technology is going to be used for game playing or any other application. So in this process, the tracking is very important. How am I going to track certain objects? How I'm going to identify them, locate them, use them for next level? They're very important. So in the tracking case, the tracking is very important. If you want to have the tracking to happen, how we are going to tag, I mean, a particular direction of the HMD head-mounted display, and accordingly, the VR graphic scene is going to change. So that's very important. But this is actually many customized tools are exist. See, try to understand how a hard tracking and hand tracking. So this head tracking and hand tracking. So when we make the head tracking, see subject to specific application, what type of graphics scene changes happens. Other than head tracking, hand tracking, subject to what type of commands or what type of movements you give. Accordingly, what type of virtual scenes to be generated. That's very important. I'm going to walk through a particular virtual scene and how the objects are going to, I mean, react. It's very important to understand. And how I'm going to touch an object and deal with them and close it. So it's very important how the tracking is going to be seen here. And when this tracking is not proper in the virtual reality, the experience going to be seen by the user is very, I mean, low. So when we try to, I mean, require tracking for all these purposes, like want to catch an object in there and we want to make some changes according to the changes of the HMD and hand tracking devices, and similarly grabbing an object, etc. For all these, we require some technology of tracking, and there are some complex tools exist for that. And we should always, for this particular thing, we should always provide the positioning information and the orientation information. Because that's very important to understand those particular features here. And similarly, mechanical tracker, some mechanical orbit joint sensors you're going to use. I think we have talked about applications in various other, but automobile and civil engineering, mechanical and civil we are not talked about. So somebody give us an example in mechanical engineering or some, I mean, some automobile industry. How I'm going to use? Somebody tell me. Anybody? Anybody from mechanical engineering?
Yes.
Yes, please tell me. Just imagine you have a virtual reality technology of your case study, or you can say of your class. So how you are going to use it for a specific application? Computer aided manufacturing, where we talk about CAD. Computer aided manufacturing, I'm going to develop a product, or you can say design a new product. Developing a product is different, design a new product. And mostly in automobile, mostly, not all, mostly we talk about developing the product. If you see, there is a variant, we come up with some other variants and higher version of that eventually. Sometimes also a new product comes. So mostly the development of a particular thing is very, very important. So how are you going to use that particular technology? Here specific like before a vehicle or before a particular variant is going to be launched. What I do, when you have such particular robotic type device with some mechanical arms and joint sensors, I try to, construct a 3D structure. I use some 3D printing automated prototype of that particular product which I'm going to launch, where people can experience its features at a prototype level, its shape, its capacity, or various other things. And with respect to the customized design, which can be changed over a graphical scenario, how a better product can be designed or refined over the times of iteration of development process. And not only that one, if I can construct a prototype version of that in a virtual reality environment, same time, I can also see the possible problems that the product may face whenever it is launched, and which can be foreseen, and possible remedies can be used. Identified to avoid this rather after launch or scale production, calling back all those vehicles for some repair, for some bug, for some defect in particular fuel tank or any engine, etc., etc. Before the actual production, if you have such a microscope where we are going to see the production of the object at a prototype level and see and analyze their behavior. Obviously, there is a lot of course, such a system should have higher expense to deal with such a complex production process wherever it involves some defects. Any doubts or any suggestions from mechanical engineering background, faculty, or anybody else?
Someone is from mechanical department.
Anybody? Nobody is there. Madam, your voice is cracking, I think. I'm unable to get.
Someone sir. He's from mechanical. Please unmute and
Yes, please. Okay. If there are no doubts, that's fine. Similar way, just graphical interface, how we are going to have this input to output, how the transformational mapping happens. Just human computer interactive mode, when you talk about how a virtual reality user can see that, you try to look into it. If there is if there's an input and output scenes, how an input scene is going to be transformed to the output scene. Because when you see the user perception, we have like motor and sensory channels when you see, and of course some autonomic channels, obviously. So when we have these sensory channels like visual, oral, tactile, and propensity, obviously there is some. When the sensory channels capture the data, and when the motor and autonomic channels obviously try to respond with that, and this maybe type of body movement, voice, and these other autonomic responses, how the positioning can be identified, how the speech recognition can be identified, and how this type of EEG, EMG, fMRI, and all the other type of data is captured, and how the input is going to be reflected over some, I mean, VR device technology. So to that effect, we require a lot of hardware and software technology which we try to use. We require wearable machine capture to the suit, which we try to use for some data collection, and then which typically consists of some 8 to 17 sensors, of course, with wireless data transmission, and normally its range lies around 30 to 40 meters, 30 to 40 meters, and some latency 7.5 milliseconds, and some small frame precision as well. Normally, these type of motion capture tools, they always support I mean, high range of motion and without any ocular stimulation. So, how you are going to use such a particular understanding of those tracking features, etc., by capturing the data from this wearable motion capture. The application may be like gameplay, where a person is sitting and using this wearable motion capture, and uh, the objects in the game going to respond accordingly, whatever the features that are captured or whatever the tracking it is done based on the device. It's very, very important that must be a real-time system and highly accurate. It should be, and without much latency, and same time how it is going to interact in real time, and the data is going to be reached over the network. And in natural feature tracking, we say, as I mentioned, tracking is very, very important. And in natural feature tracking, normally we have some identified features and some contours or some edges, etc., we exist. Normally, these, when we say natural cues of these scenarios in the graphical environment, we normally have features like edges, surface textures, some key points. See, these interest points or key points are very, very important in understanding the tracking mechanisms of that. And similarly, these type of thing no give they don't give any this artificial understanding of this surface features and all those things. So the problem is how we are going to track those features specific to a certain scene, specific to certain case studies, certain application, and how we have trained our particular model such that these things can be captured and used for some real-time application. Therefore, tracking will do, as I mentioned already, tracking is very, very important. By many, many ways. Normally, tracking by key point detection as a conventional way of dealing with trackings. Uh, Normally, in this case, what we try to do, first we identify the targets in every frame, and then tracking and detection, we try to identify simultaneously. Here, what happens normally, camera image, and once the camera image or actual image is identified, are fed with, then recognition part, when we try to look into, we have the key point detection, and of course descriptor creation and matching, how it is going to exactly match with the particular scene, and then some answer outlier removal, and then estimation of pose and the refinement architectures we are going to use it here, and finally the pose will be identified according to the given camera image. So therefore it is very important how such a key points are going to be used by various users to understand the inherent features or inherent meaning of those scenes, such that there's some particular decision of this can be taken. How to move, which direction, what is the speed, or you can say how to go to next level. And so the key point detection is very, very important. Otherwise, it is difficult to, get the experience of that particular thing over a span of images. So there are various tools exist, some fast tools, etc. Uh, then we take this to all pixels of our image. We can obtain a set of key points, and then we can analyze and describe those key points to give a better experience. So when it comes to the technology part, tracking, as I mentioned, see now we are going inside that one. Now how we are going to create the scenes, how we are going to control them, how you are going to go to the next level, how you are going to identify features, how you are going to track them, how the tracking is used for some purpose, moving the level to level running of a particular thing. So all these things we need to understand. So that's why there are marker, natural feature tracking methods, etc., etc. I mean, in marker tracking, they don't require any supervised data to be exist. Normally, no data set is required because normally marker data sets, marker trackers are, markers can be identified whenever looking into this scenario by just shape or by way of its representation. So in case of marker tracking, really, high level tracking is not required and very less requirement is there. And the graphical environment must be having, I mean, some connectivity or instrumentation. And normally when we full view of this thing, only then the markers usually identify and they can be used for the level by level understanding of the scenario. In natural feature tracking, here normally we have a database of key points we already specify like a supervised data. Then natural features targets, and then whatever the location where we have must scope or attention, then accordingly we are going to understand and identify what exactly the tracking we require here. As I mentioned, the actual expected value of this market by 2025 is, I think, around $35 billion in the globe. And with all these applications which were specified, and with all those changes which you have learned, and the challenges which you have foreseen, I think there is a lot of scope for doing research in this interdisciplinary, where we have applications of healthcare, engineering, real estate, and then defense, of course, and then gaming, so various other concepts. Any doubts so far before we see the other concept, non-immersive VR systems, etc.? Any other doubts? Before we also look into deep augmented and any other technologies here. Okay, there are no doubts, that's fine. So when it comes to the concept of immersion, as I mentioned in the very first slide, somebody tell me what are those three characteristics of virtual reality system, what we have looked in the beginning?
It's immersion, interaction, and imagination.
Yes, that's very nice. Thank you. So when it comes to the immersion, the first and foremost characteristics of this virtual reality concept, it is very, very important how a user is going to see the effect of immersion to experience the highly graphical nature of the object, or you can say the scenes of the real-time images in a graphical environment. Now, when we come to such an experience, sometimes, as you mentioned, that is the reason to come out of this virtual reality and slowly coming into augmented reality side. To have such a relaxed mode of, experiencing this type of thing, people started developing a slightly a variant of this one, like a VR system, but it is not a fully operational like in a closed environment. It's like a desktop VR system. That's a desktop VR system. Or similar we call as fish tanks or window or many other names we have for type of non-immersive VR system. So when you say non-immersive VR system, so eventually see when you see in a HMD head-mounted display, when you look into these experiences, the level of experience is highly, different, right? Obviously, when it comes to watching those same immersions, same changes, same scenarios, in a you can say not exactly immersive, but some low immersive or non-immersive type of video. You're watching on a big screen rather watching in a HMD head-mounted display device. So compared to the HMD device, the desktop VR systems, when you try to watch it on a large volume monitor, definitely there is some change, but the type of graphical experience which we observe in a closed environment would be, really better. We cannot always afford also to have all such experience every time in the same level. Therefore, such a non-immersive VR systems have been introduced where people try to understand how it is least. The immersion effect is little less, and at the same time, the cost of the also slightly less as compared to the other one, and the hardware requirement also slightly nominal compared to the fully immersive. Same time, you can also interact with some 3D environment when we are trying to use with a stereo display monitor and glasses, obviously, right? And when it comes to immersive VR system, as I mentioned, already I think we have talked about that. We have a head-mounted display device or virtual reality goggles, which we try to see. And these HMD device gives our tracking devices are these wearable sensor capture tools, suits, etc. Data gloves and others, data gloves for this medicinal healthcare applications where we try to capture them. And many other computer generated 3D animation images, 3D animation systems, devices, all those things which you are going to use it for some application of certain nature. So any doubts? Non-immersive VR systems or desktop VR systems? Perhaps there is a test, I think. We are going to see how we are going to understand these concepts of this. But at least you should understand the basic difference between a VR device and AR device. At the same time, not fully immersive VR system. It's a non-immersive VR system. My question is, can I call a non-immersive VR system as an augmented reality system? Same thing. This one, desktop VR system, is it augmented reality system? Is it an AR device or a VR device? Because we normally talk to the virtual reality system to be fully immersive, right? That we have seen in the previous these comparison, scene generation, hardware, and then that immersion effects, tracking. But what here is now not fully immersive. Can't we call it as a VR system?
I don't think so. We can call it artificial because all the five senses are not getting involved. It's not completely immersive. So might not be called as a VR.
Yes. Now see the same experience what we are seeing here on the slide. If you have on a small monitor, on a small mobile phone, then see the effect of virtual reality. I mean, the virtual reality technology is even more. I mean, almost ignorable. We cannot see much interaction or much immersion, obviously. So obviously, what happens? That will be like going out of completely virtual reality side to the other part of that. When it comes to non-immersive VR system, because we are coming out of it's not a closed environment, something like this, just to have some 3D experiences and all. So here we try to have a different way of, I mean, different type of hardware installations. Like you see, if you see the desktop VR system, there are certain features where the screen size is very high. Same time, it's not about just the size of the screen. The way it gives certain features to the user cannot be given by the normal augmented reality devices. That's why still, though it is not fully immersive, we call it as a VR system. Don't think that because in the beginning we mentioned VR system to be fully immersive, right? But here, though they are not fully immersive, because of its incident like 3D integration and various other features and its inherent, I mean, communication levels, eventually that is called as a VR system, but not fully. It's non-immersive, but still it's a VR system. But when it comes to a mobile phone, similar way I can have some interactions, I can have some apps and all. That's augmented reality system because there you require what? Heavy communication with outside world. Here, though it is a virtual reality system but non-immersive, same time you are going to have what? Communication with your own, I mean, say system, not a frequent communication with the outside world, right? That's why there is a clear distinction between a VR systems, AR systems, and non-immersive VR system, right? Now, if I ask you to write a diagram of AR system, VR system, and what non-immersive VR system, I think that should be a question for quiz something for the today exam. I don't know. I'll ask madam to include that. To write a Venn diagram in your opinion, how a VR system, AR system, and a what non-immersive VR system can be. Just to try to think about that. Okay. So similar way. So thereby, as you mentioned, immersive VR system, obviously, we have seen the previous 17 sensor that motion capture shoots. Similarly, we have others, sensors and various other fires. Yes. When it comes to sensors, we have magnetometer, accelerometer, gyroscope, etc. When we look into this, normally we require these three for various purposes. When we come to magnetometer, We normally used to measure the magnetic fields for some specific tracking purposes or any uh, graphical experiences, creating some skins. And this magnetometer also, I mean, used as a compass. And similarly, accelerometer, because the role of compass also very very important in the to look after the directions of that. Because now, when a particular directionless device is there, it is difficult to identify the routes in the next level, and they cannot be used for next level, right? Identify normally which particular side the device is facing, because that is also very important. The direction also matters when you come to scene generation or level by level moving tracking. Okay, and also this accelerometer is used to compute the acceleration with respect to an axis, maybe multiple axes. That's fine. And it also detects the position, velocity, vibration, and various other things such as orientation. And when it comes to gyroscope, as I mentioned, uh, normally this gyroscope concept, like we use for measuring, maintaining the angular velocity or this orientation type. This gyroscope senses changes in twist and angle, obviously, because that is also very important to see this. Just hold on. So, it is very important to understand the concept of these, I mean, these hardware related issues also, because when you try to make such a creation of this, obviously we need to understand how it is going to be used for specific purposes of this. Now, another application, some civil engineering applications are various other. I think we give a small break here, I think, and then we'll come after 15-20 minutes. Madam, can we give a small break here?
Sir, sir,
Hello?
we can give break, sir. No.
So we'll meet after 15-20 minutes maximum. 15 minutes is fine.
Okay. 3:35.
Madam?
3:35, sir.
Oh, so we'll meet after 15 minutes. Right?
Yeah.
Thank you.
Maybe one of you want to interact with the data center and the free center. Because you can something to respond. Anyone? Yes. Anyone of you are interested to discuss this? You can we know so much as a free representation.
In the meantime, Alex studies in first year prestigious music competition. After the team writers room, Adam strums his guitar solo, desperately trying to avoid detection. Adam gathers the courage to perform in park, captivating smooth eye with his excellent intimacies. Jen accidentally stumbles on Adam's unfunctional units. His disapproving means filled with anger and disappointment. With his father's disappointment weighing heavily on his heart, Adam takes the stage to lose the competition, pouring his emotions into a powerful, heartfelt performance.
So we can start with.
Yes, madam. I'm ready. Am I audible? Please come.
Yeah. Yes, yes, sir.
I'm sharing the screen. So, as I mentioned, the applications of virtual and augmented reality is also very important in other domains such as this architectural designs and then some civil applications and all. Where assume that there is a builder who is going to construct some high-end building. If we can construct a 3D virtual environment of that particular structure which is going to construct, and a small demo can be given to the participants or to the customers before the actual construction take place. So now if you observe, if the client is supplied with a document of this, the possible structure of this particular flat which is going to construct, then a simple see now as we recall the virtual reality and the basic requirement of that, then we take the realistic images and try to make the scene generation based on the realistic images. If there is a particular document that is given by the customer to a builder, the customer can forecast and then make a particular requirement of his block, and a 3D graphical experience is given to the user in this virtual reality, I mean HMD, where a user can enter his particular roadblock before the actual construction will take place, and possible suggestions or improvement can also be taken care. So it is not just, customer point of view and application of virtual reality technology I'm going to talk about. Same time, from the builder point of view also, before actual customization, if you can manage to give a small experience to the user, and same time the builder can also see how a particular space optimization can be achieved and the better designing can be uh, converged. So all these technologies can be useful for such a diverse application when I looking for. Not only that, when you complete such these architectural designs in that this virtual reality technology, We can also talk about optimization, how a particular group of customers can have an experience in this particular group of uh, the concept of making an architectural plan in a virtual, reality environment. It requires a lot of understanding about the possible designs and the optimization. So, same time, we should have some concept how we are going to. And similarly, this hardware concept, how we are going to use different technology. Now, the basic structure of this virtual component architecture, we are component architecture if we look into. There is a user specific operation we define first. Now there is a VR engine that takes data from the input devices, what and all the sensory data which we are going to capture to expect the actual output seen from the graphical environment. So the main core component of this is a virtual reality engine. So in the VR system, whatever the operation data is given to the VR engine, of course, which is a combination of software and hardware, the software and this data sets. From this database, when the transformation is generated, the output device is there, which can give the sense of data to the user, where the user can see the actual experience based on the whatever the input we have specified. That's why we call it as an interaction also, and imagination also one of the characteristic when we try to define the actual effect of the virtual reality system architecture. So here the role of VR engine is very crucial in making such a transformation from the input device to the output device, where like data to data, but same time how the software and database operations are going to be performed here using a VR engine. And the same time, when we talk about the hardware requirement of this one, to specific what and all the data transformation we are making to this particular application or case study, suitable hardware architectural designs like we have talked about 17 sensor wearable capture shoe and we also talked about the gyroscope, sensors, accelerator and many other. So all this is concept to be understood such that a VR engine can work effectively on those uh, input data to create such a graphical output to understand this one. Now, when we come into understanding the field of view, how a virtual reality is going to be affected, the experience of VR system is going to be affected for a different field of view. The role of this particular field of is very important, particularly the concept of virtual reality, not the augmented reality, because the field of view has they have a wide field of angle. When you look into how a user is going to see the experience or make the experience. So normally we define the field of view as the total angular size of the image which is visible to both the eyes when we say. So when we require such a field of view such that the person is going to have an experience of such a wide coverage, we need to define how the particular scene generation can happen with respect to this particular field of view. So because the role of field of view is very, very important, particularly to HMD which we are going to define. This particular field of view, it describes the how an angle through which the devices are going to have particular this electromagnetic pickup. This electromagnetic radiation, when they try to pick up, how the devices is going to transform the data to a specific level of graphical experience, and that is very, very important to understand. Therefore, field of view plays very crucial role in giving a better experience to the user. And obviously, if you observe, or if I ask you a question, field of view is very, less for virtual reality or augmented reality devices. Try to answer. FOV, we expect to be high for VR devices or AR devices. Then, if you observe a point, we have talked VR system to be fully immersive. So VR systems are to be fully immersive. Normally, we expect to experience such a fully immersive effects, we should always have a large field of view. So normally VR system to contain to have large field of view compared to the augmented reality systems and their coverage compared to this one. Typically, we can see an example how a horizontal field of view is taken care and how a vertical field of view is considered. Now, for VR devices, which field of view is high, horizontal or vertical? Somebody tell me. Is the vertical field of view is high or horizontal field of view is high for a VR system? HMDs, that head-mounted displays which we have seen, it appears to be having the field of view to be high in the horizontal field. Horizontal field. When it comes to vertical field of view, they tend to be less compared to the horizontal field of view. Right? Someone tell me why? Am I audible clearly? The question is here is horizontal field of view is high compared to vertical field of view. Why? Or it should be safe. Safe. When we say when we are trying to make this graphical experience to the particular user who is using, if you can observe the optical, I think this particular thing, how the particular lenses are going to capture that particular images and how an experience is projected on the VR display screen. These VR headsets are going to play a very crucial role. How this particular scene is going to be, projected on the, human eye, such that the person can feel the graphical experience. So eventually, if you can observe, normally this vision system, the graphical field of view used to be wider compared to the vertical field of view. If you can observe, therefore, field of view for this particular way of architecture should be more uh, effective when we try to give a better experience of graphical nature to the user. And frame rate, another important factor in VR systems is frame rate. Normally, it's considered to be the number of frames or images which are trying to project or display per second. The reason is we may not have a constant frame rate for all type of VR or AR systems, but when it comes to the frame rate, time to time, or scene to scene, or scenario to scenario. Therefore, these number of frames, how we are going to project, will be decided by what type of experience we are giving to the user. Frame rate is very, very important. At the same time, application to application, as we can say, like for a specific virtual reality device, we cannot have, we may not have fixed frame rate for all type of operations which you perform using that. But however, normally a typical frame rate to be like greater than 25 frames per second to be ideal. We consider to be the user is going to take a better experience. The user is going to take a better experience with 25 frames or more per second. So, but on an average, when we try to see these existing, VR systems, we consider to be 30 to 35 or 40. But when it tries to be greater than 25 to be a moderate frame rate, which user can sensibly feel the experience. Now, having seen all these different technologies and then hardware and software technologies and the type of applications when we try to look into, what type of possible applications other than what we discussed? Because many challenges we are talking about how to make the tracking, how to make the key point detection, how to identify the features, how to make the optimization, and the type of application in civil, mechanical, and various other domains. Beyond this, what is the actual future of this the application as we have seen? Now, case studies and applications when we look into rather challenges, as we mentioned, how performing surgeries can be done by medical practitioners from a remote location. Uh, Same time, the concept of accuracy and latency issues are very, very important. and an uninterrupted controlling environment is required. So, what are the prerequisites when we say this is an application in medicine or healthcare technology? What are the prerequisites you expect to be? Tell me somebody. Anybody? If you are going to address this particular challenge that I'm going to develop a particular robotic system or a robotic arm that perform a small surgery, a minor surgery, where a doctor is going to operate from a remote location over a wide network. What is a wide network? I mean, over a wide network from a remote location. Tell me, what are the operations is going to, I mean, what are the prerequisite you should have for this? Tell me somebody. Do you require, of course, we require virtual reality. And next, that's all. Somebody? Do you require any computer vision or image processing? Do you require IoT for robotics? Do you require machine learning? So all these fields are interchangeably required when we say dealing with such an interdisciplinary research, where you require some, I mean, communication, uninterrupted communication over some reliable or controlled environment. What you mean by controlled environment is obviously what is the reason I talked about the latency issue. So how a particular user is going to interface in this particular controlled environment over those whatever the data, like maybe video images or video or audio or whatever the images which you're going to have. And then an IoT system, because I'm going to have a robotic arm which can control these operations over a uninterrupted communication devices. And similarly, dealing with phobias, how fear of heights and all, and some dealing with these facing the spiders and other. Some people have certain issues with, I mean, public speaking. They are very okay, but they are unable to speak in the public. You can also, so all this is which we cannot do in a physical level, in a physical thing. The same thing you can be trained upon a virtual environment, and that can be used even driving also. Nowadays, many of the driving these schools, they try to, I mean, train you first for a week or two in a particular 3D, I mean, virtual reality environment. So once you are, I mean, little okay with the actual system, then they tend to use the actual system, a physical system which you are going to learn about. And then dealing with various phobias and therapies, and then education, online education, offline education, many of the application where it is possible to use this VR technology. So how you are going to train them and how you are going to understand them, that's very, very important. Now see, you can understand most of these technologies when you look into, you require a lot of supervised learning and unsupervised learning as well. Because if you are going to train a robotic arm to perform surgery by the instructions of a doctor who is located far away from here, eventually the particular robotic arm must have been trained on some similar way of data, which has arrived at some, I mean, continuous or at some time intervals. Eventually, it has to be trained on a similar patient where a similar surgery was already performed. So therefore, it's very important how such a supervised data is going to be identified and then train the model. Then only you will be able to train your VR system to that effect of making such an operation or performing surgery. And then mixed reality, when we say sometimes augmented, we also call it mixed reality, because here normally we try to have a lot of interaction with the real world, and also the communication is in wide variety in nature. Same time, when it comes to virtual reality, same time you are in closed environment, but you need not have much interaction with the outside world. The concept of VR to AR not remain there. It also went to the distributed virtual reality concept when it comes to. So when the same virtual reality experience which is implemented or which is uh, developed, that can be simulated on several computers at the same time, which are connected by some particular LAN, LAN area, or any other small area network. Then with that particular real-time interface, people can talk, people can interact in real time, they can share some virtual world, etc. So when we talk about now, can somebody tell me where do we really require distributed virtual reality concept over a conventional virtual reality? Tell me now. Where do we require concept of distributed virtual reality?
When we
Other
are
than
connecting
other than
virtual
gameplay,
meetings,
other than gameplay.
virtual meetings
Yes,
over Zoom or any other things.
yes, that is one good application for this. Any other? Virtual meetings can also
When the
be used in
students
real
are
time.
being trained,
See, but see,
maybe when the students from different geographical locations.
mm, yes, they can also get connected. That is one. Any other? Gameplay is one of the good example for this when we say how a different levels of gameplay can be integrated and played on the same different monitors such that they can be integrated and working together. So distributed virtual reality for gameplay and performing certain even this complex medicinal operations also they use, and in addition to that these some e-commerce application also we can use. And this what I was referring, and some VFX movies and some this high-end graphics movies and all those things also this concept of what the distributed virtual reality is heavily used. And I think this we already talked about non-immersive virtual reality, immersive. I think immersive already covered, and then augmented virtual reality. Hmm. It replaces VR system also. I think a kind of way, but I think we look into the concept of this. Now, see, we talked about virtual reality, augmented reality. Now, how an augmented VR concept can be used, if you can look at it. Tell me, what is the difference between these two? We talked about virtual reality, augmented reality, distributed VR, non-immersive VR system, right? Now, augmented VR systems, what is the difference between these augmented VR systems? The VR system, we tend to have what? No much communication with the outside world. Augmented VR system, what? We tend to have some communication. We would like to have some communication with the outside world. For what reason? It may be like application specific. Now, for some, like this automobile application or some like this vehicle repair, I think you are in a remote location, you are unable to do that. Then you cannot simply make a video call and all. What you can do? You can have a VR device and whatever the images captured, because again they require a communication to the outside world, and the images captured, and a person from different remote location can observe, and also same time otherwise on the other contrary, if you have a programmable VR which is trained on some supervised data, what is training, that can also suggest you for possible repairs. So the moment you capture the image, and it tells you exactly where the possible location is, where the problem is, and it will ask you to fix that particular, something like that. So the beyond VR, what we are adding here, we are trying to add here to uncover the communication, what we have no in case of virtual reality, and we try to have a communication with the other outside world same time, and to get some possible suggestions how the application can be addressed. Right? May not be automobile, and a similar way. And of course, student in the same augmented VR device, if a student try to, I mean, get some questions to be answered by some expert when they're trying to see the question. Means what? The moment a question is captured in a particular given frame, the question is understood and analyzed, and the answer is forecasted, or you can say showcased on your virtual reality screen as if like you see on the blackboard. That's called augmented virtual reality. Beyond, in virtual reality, what happens? There is a question you can see, but communication won't be possible. That's why augmented virtual reality is also very important to understand. So similarly, for other applications, for training people and these athletics for training, I mean, many people, I think, to control the emotions and to improve the psychic abilities, many of the athletes and all people used to, I mean, participate or get trained themselves on these particular technologies, where they are heavily undergone process tough training in the virtual environment, and they try to control their psychic abilities. Okay, and also many other game playing and then psychological analysis, play dealing, etc. So distributed virtual reality concept is also very important to understand. And the various technologies of virtual reality hardware, like let me say, this cave technology, uh, cave automatic virtual environment technology. So how different moves of a particular real scene can be identified and the movements can be decided, how a tracking can happen. Because the tracking is a major challenge in virtual reality. So if there is a head tracking system and how it continuously adjusts the stereo projection, such that it does identify how the movement of a position, what is the current position, and how the movement of a particular thing can happen. So there are various technologies, cave technology and many other technologies. Similarly, data grows, as I mentioned, diagnosis, and then treatment. When it comes to developing a technology hardware, see, when you come to engineering point of view, the scientific point of view, the people are working in the domain of virtual reality technology is not just coming up new computer vision technologies, or I mean models, or you can say new uh, uh, HMB models. But same time, we need to understand how we are going to develop these particular hardware, like as I mentioned, 17 sensor wearable suit, wearable motion capture suit, and similarly that gyroscope, accelerometer, sensors, data gloves, smart gloves, robotic arms, prosthetic devices, many. So how these hardware technologies are going to evolve? Now how this particular data group is going to have some output of sensors on all the fingers. If you can see the inside look of this particular the globe, if you see it has the sensors on all the fingers, and every position and orientation of this particular fingers and the direction can be tracked, and eventually it can be identified in which direction they are going to track, and same time how they are going to identify an object, how they are going to hold an object. So my question is like, can we have one such data group that works for all type of handling movements? No. See, if you're going to have an operation, I mean a particular task to be performed for game playing operations, eventually the type of data you have, it is different. Here, see, natural interaction with virtual objects. Here we are using hand gestures. So when hand gestures are recognized, every hand gesture you are going to have is not same for different applications. So how this interaction is going to happen for different virtual objects by various hand gestures? Then how recognition happens? So if I'm in a game playing, some particular game playing, how I'm going to hold an object, then how this particular tracking is going to give you a next move. That is different. Same time, how this particular technology is different for other type of like a doctor's diagnostication. So if such a hand gesture recognition is required, then different, maybe different set of sensors you require. Placement of sensors may be different, and even the type of sensors also obviously different, right? So hand gesture recognition and this changes in the density of particular location and many, and surface roughness. and sense of touch, different type of senses I may require. It's very, very important how these particular senses are going to be identified and how a particular such technology can be evolved to understand for this specified application. And obviously control devices, how we are going to fab some control devices to control the objects in the virtual data environment, three-dimensional point of view, because very, very important. Otherwise, without a sophisticated hardware technology, it's very difficult to understand. And also language modeling. So just an example how the interaction can materialize when we are trying to make the concept of virtual reality and how it is going to be forecasted. Yeah. So how an object is identified in a, see the as I mentioned tracking techniques, interaction technique, and then these sensor capture. All these are very, very important. And how a particular thing can be identified, how a selection operation performed, and grabbing, how I'm going to hold an object and that can be identified by particular which particular operations of this one, and how an object will be manipulated when I look into it. Then how an object will be replaced. So all these things, operations are very important to understand to application specific point of view, particularly in the 3D environment. And navigation, again, tracking, application, selection, manipulation, similarly navigation technique. How we are going to see the navigation of a particular direction in the particular direction, whether it's a target based or node based or other directional velocity type, hand directed or gaze directed, and similarly other way of directing with this with a different feature extraction. In case of target based, the number of features or the feature extraction is very, very crucial. So the navigation technique can vary from application to application, and your what you call is scenes, scenes to scene, or real time real scene images to images. So accordingly, the these techniques can obviously route planning also for various applications like smart traffic applications, and then traffic management applications and various other. So the distributed we are already talked about, and broadcasting, multicasting, unicasting, and various other applications as I mentioned, other than what we have covered, industrial and manufacturing, and then healthcare, retail, e-commerce, marketing, advertisement, education, military, emergency services, etc. Some of the other applications. We are done. Just I will cover few more healthcare technology applications using virtual and augmented reality. Then we will stop it. Give me another 15 minutes time. I'll cover this. I'm just opening another PPT. Just give me 1 minute. Can you see the screen? Please confirm.
Yes, sir, we can.
Yes. So on the other contrary, when we look into the applications of this biomedicinal and then other healthcare technology application, where and all this concept of virtual and augmented reality will be used. If you go with the case study of like brain computer interface, where you try to capture some brain signals and then use it for some real time application, for some IoT application, TMS application, many other applications are there, which you see in the next slides. Now, before we see the actual applications with the orientation for virtual reality, now just now assume that we have some brain signals in our hand, and I would like to collect somebody's brain signal. The type of signal normally when we expect from human beings like EEG, fMRI, CAT scan, PET, PHMRI, TMS, this transcranial magnetic stimulation, etc. When we try to integrate, see, already we have talked about in the previous slides how we are going to use the concept of virtual reality when it comes to human-computer interactive systems. As I mentioned, the prerequisite to it, when you are going to understand this concept of using VR or AR technology, should have the basic knowledge of IoT, human-computer interactive systems, and of course VR technology, the basic technology, computer graphics and all. And same time, you also need to understand machine learning concepts. Now, I'm going to use a particular human computer interactive device. Let it be some kind of EEG machine where I get some brain signals from. Now, of course, I use these signals to control some, specific application, maybe smart wheelchair or whatever it is. I'll connect to my virtual reality application. Now, when it comes to EEG signals, assume that already we have seen many as like a lot of other signal, CAT scan, PET, fMRI, ECG, sorry, EEG, EMG, and all that type of signal. But here we use mostly like many people who try to have such an application like TMS or any other type of application, deep brain stimulation model. They try to use EEG signals because of its inherent features and various easy to pre-process, easy to digitalize, and translation, classification also easy. Normally, when you are trying to make such an interface between a human and a computer for a specific VR application, we have to understand how you are going to record the data flow. First, you need to make an amplification of the signal. I mean, as I mentioned, see, brain signals come, right? Neuron to neuron communication. When these brain signals are identified, this electric signal, they communicate at light speed 250 miles per hour. So, how these signals are going to be captured? And how these captured signals are going to be, stored in a workstation further. Normally, the signals which you are capturing, it cannot be captured directly in the same manner. We need to have an amplifier. We need to, have some filtering. So we use some sophisticated technique for that. So here, now when it comes to the concept of like the front end device is my virtual reality device. Now I have a subject or a patient. I have my PCI interface. Then what happens? I try to record the brain signals and then amplification, then digitalization, pre-processing, classification. Then finally, I use it for some specific real-time application. Now, how I'm going to develop a device, maybe a VR device or some device based on somebody's brain signal and analyzing their certain things like now based on I'm going to develop a VR system like based on my brain thoughts I'm going to something forecast in the screen. I visualize in my brain something and I see that particular object on the VR device. Is it possible? See, whenever I say human computer interactive systems and virtual reality devices. Now we have human computer interactive system, some amplifier, etc., etc., and data comes to our workstation where the brain signals or arteries, whatever it is. Once the EEG signals comes into your device, comes into your storage device, then how you use that particular data, then how you connect to a VR technology, maybe for some medicinal application, biomedicinal application, or some other healthcare technology application, or this application. I imagine something should come on my VR device screen. That's very challenging, right? So now the basic challenge here is what type of features you are extracting from your, I mean, this human computer interactive system, and how this particular data is going to be used for this type of device applications. Okay, you see, you try to understand a system for controlling a device, maybe a computer, or maybe etc. Wheelchair, smart wheelchair, or a VR device, or a neuroprocessor device, or an IoT device. Now, this particular device function based on what human intentions. That is read by the human computer interactive device. Again connected to my VR technology. Now I'm talking about the case studies which we are going to talk about. Right? So we are going to have human computer interface, some direct human interface type, then some translation device. Now this translation device tell you how you're going to connect your data to the your HMD, head mounted display. Right? You just try to see how this entire communication system can be TTD communication on this one. So there is a subject, and we're going to take the data from there. There is an amplifier. It will be amplified about 10,000 times and filtered. Then data stored in a workstation. There is a feedback screen. Then the data is recorded like trial one, trial two, trial three, etc. So subject one, trial two, trial three, etc. Subject two again another trials. Some set of around 10 to 15 trials you can take per subject. Fine. Now if you can visualize what is actually about the data collected from the human brain. So you are visualizing such a signal onto the somebody's screen. Fine. It is like mapping of human thoughts to your specific real-time screen. Obviously, it's very challenging because the signals are very raw signals and very clumsy and very difficult. You require a lot of pre-processing, a lot of classification, etc. Eventually. But I think people started working on it and tried to get that. And there are some customized software tools exist for this. Even some IoT applications also I will see how it. Then this neuromodulation techniques, how a particular person with some certain issues, maybe spinal cord injury, etc., etc. How this neuromodulation can help us to treat certain problems or health. There are three types: deep brain stimulation, vagus stimulation, and transcranial magnetic stimulation. This DBS, deep brain stimulation model. Normally, if what happens, just to talk about the actual healthcare problem, when we look into, assume that the person with patients with Parkinson's, epilepsy, stroke issues, or any other major problems like some OCDs and PPCOD, many of the problems. Normally, these type of treatments, they place an electrode inside the brain, and there is a battery backup, of course, running down. So this deep brain stimulation lead, and when the electrode is connected, obviously, when the connecting wires capture the data signals, you try to analyze it. So here, what you do? Now we try to assume that is epilepsy, stroke, or Parkinson's disease. Now we try to, train the subject or the patient on certain virtual reality, demos. Assume that the person is drowsy or very inactive. Then what happens? You try to make such a data collected when the person is undergoing for some treatment. Maybe it is a DBS type treatment. Then we try to connect the signals before the treatment and after the treatment, and then treatment in the sense the how you're going to experience the VR device, like for your spider phobias or public speaking, etc., etc. Then we try to analyze. But of course, we have to understand these deep brain stimulation models and all. We have to use invasive mode of data acquisition. When we say it is normally done by some doctors or medical practitioners, we normally go for non-invasive mode of data acquisition when we look at it. Similarly, transcranial magnetic stimulation. This is also one of the way how people are going to, use for some problems to deal with depression and mental stress to identify. Now, if I can have a human interactive systems, I can make an application influence of virtual reality system or influence of virtual reality on the mental state analysis of a person. Means, if I am so upset or if I am not feeling good, when the mental state of a person is very poor, if I can use this VR technology and the person can have, of course, certainly there is some changes in the mood. Eventually, the person is going to be normal. Or you can see we are going to see how the brain signals change before and after the VR treatment to the person. A person, not for a common person who is undergo for some psychological issues, some mental problems, and many other issues. So normally these type of deep brain stimulation models, like this TMS transcranial magnetic stimulation model, here what happens, there is a treatment device, TMS treatment device. Here normally this is non-invasive procedure, this is not invasive. Here this TMS device uses some magnetic pulse. This pulse normally they stimulate the brain cells, which are actually the reason to control the moods. So the brain cells which control the mood, if there is a the TMS device which stimulates the magnetic pulses, then what happens? These pulses, whatever this TMS device uses, these pulses trigger some electrical charges. Now, once those charges arrive, then these particular charges cause some specific neurons of that particular brain cells which are actually controlling the mood. They become active. Then what happens? Continuously when you give this short pulse of magnetic energy on those limbic structures of this human brain, see that limbic structures become active whenever there is a there is a flow of these there is a stimulation of these pulses. When the brain cells become active, we can measure the brain cells and see that how far this treatment is successful. Are you following me? So it's very important how we are going to connect this application. Why I'm giving this case study is very important. How you connect to some VR technology. A person with, some psychological issues. I'm going to give some positive treatment, some VR technology. I'm going to use some HMD videos and all. Where he understand, he reads them, and then use it for some real time application like this. How it is going to influence him. Everybody. So if you want to do such an application measuring the mental state analysis of a person while the treatment of or you can say while using that particular VR device of certain demos, whatever it is. This requires eventually human computer interface, machine learning, and VR technology, both. And similarly, you can also use some for some IoT applications. Like if there is a person with a missing link, the neural prosthetic and rehabilitation devices when you do, here this particular thing try to replace or improve. Normally when there is a person with these problems, the impaired nervous system, because it is unable to function because of this lost link, you can have a more controllable prosthetic uh, which works similar to the other leg. But here now if you can understand how this particular IoT device can be developed, taking into the brain signals may not be easy. And how we are going to train this particular subject on a virtual environment. So train my particular person, the patient, who is going to have this prosthetic device. I train him in the 3D environment because the training in normally training in virtual 3D environment is challenging. Huh? So how we are going to use such particular technology to understand this particular concept of prosthetic devices and how we are going to use the data to integrate such a, prosthetic device with the help of EEG signal, and how you train the subject in a virtual environment, then use that particular supervised data to control the prosthetic arm, or sorry, prosthetic leg or whatever it is, the device. So you might ask, what is the importance of virtual reality here? When I connect this particular device, I would like to train the subject on that before or after. I would like to train him in a virtual environment and say, see, I would like to capture the reference signal with the help of which I can control the device more effective manner. Similarly, retinal implants, how I'm going to use them for the specific applications of, but anyhow, that's very quick about that. And when we try to collect the brain signals for these all these specific applications, we can have we have to understand the states of wavelengths of EEG. We have normally beta waves, alpha, theta, and then delta waves. Beta we normally see when we are alert. Alpha wave see when somebody is daylight sleep. Theta when somebody is sleeping. Deep sleep, we get delta waves. Paradoxical sleep, we have dreaming, REM signals, and many more. Each has different predefined ranges for some specific application like this. And in fact, we can also see when a person is watching a particular some crime serials or any some violent videos, how the brain is going to influence. So we can see the influence of human brain, influence on the human brain by such particular material. How we are going to analyze it? Obviously, we require this type of signals to capture and understand how they are going to influence the human brain. So, influence of certain thing which you are experiencing in the virtual reality environment and how it is going to impact on the human brain, right? Mental state analysis and many other. And it's the entire operating environment, how we are going to have a control interface here. So, there is a front end device, maybe smart wheelchair and any other, some smart VR technology, etc. Where there is a user, there is an amplifier, there is a PCI control unit, and then where we have feature extraction, feature translation is performed, upon which the logical control interface will be there. Then this control interface is connected to device controller, which actually gives device controller feedback and takes semantic control. Finally, this device controller, based on the semantic control, make the physical control of the device which is being used as the front end. This is a smart wheelchair operation I'm giving. Similarly, you can also propose for any other VR technology, how we are going to capture, as we mentioned already. And so just entire phases, how we are going to capture the brain signals, display the signals, signal processing techniques, and then this feature extraction, translation, classification, followed by your front-end PC application using some. So when you connect such a particular VR technology, and how you are going to take the data from which particular channel, brain has already has so many channels, how you are going to use this particular technology and collect the suitable brain signals of reference and use them for this application. That's very, very important. Otherwise, it will be very challenging to take the signals of this associated. And as I mentioned already, this game playing and then these other applications, uh, supervisory candidate guidance, etc. And wearable edge devices, as I mentioned, similar to virtual reality, but this is wearable data connection of brain signals. Similarly, this one. A wearable edge device is used to collect the wearable brain signals and use them for some real-time application. And similarly, virtual and augmented reality applications for game playing using brain signals. Am I audible?
Yes, sir, you are audible, sir, clearly.
Yes, somebody, you can see I'm going to connect somebody's brain signals. Where now see here I'm not using a wired edge device, it's a wireless edge device. If you can observe, there are one, two, three, four, about five channels are there. I'm taking data from five channel and see here I have human computer interaction. Then whatever the brain signals I'm capturing, they are transferred to this particular workstation, of course by a wireless medium, maybe a Bluetooth or Wi-Fi. Then I'm going to control my this one. So if you can observe, can you tell me what exactly this application is? Somebody? It's a HCI enabled, human computer interaction enabled distributed augmented reality for game playing. Do you all agree? This is why I talked about the human computer interactive models or BCI. This is a BCI enabled or HCI. BCI enabled distributed augmented reality for game playing application. Do you agree? So now I require my brain signal. I have taken my brain signal and I'm going to use those signals to understand, how I can play a role in the particular game playing. Then how this is going to interconnect here by a wireless medium. So I require BCI, I require my augmented reality, obviously, for game playing application. But if it's maybe a distributed game playing application, because he's a part of multiple entities here. But he's playing the game by his brain signals. Are you following me? He's playing the game without touching the mouse or keyboard. He's playing the game by his brain signals. So it's a BCA enabled distributed augmented reality for game playing applications. So that's all. Uh, so the future e-learning with VR and this BCA technology, last scope is, I think we are done. Let me know if you have any doubts. Now we have, I think, another 15-20 minutes time. So let me know if you have any doubts.
Sir, one doubt. Sir, can we apply this VR technology for deaf and dumb people?
Madam, now the question is, see, when they say normal people, how do they sense? How do they sense these signals, audio or video, whatever it is? When you see brain, if you see that auditory system, what we talked about is when I talked about the human computer interactive system.
Yes. We are capturing the brain signals. Sir,
Absolutely perfect, sir. Absolutely perfect.
I think, sir, we have lost her connection. Arnav, you are able to hear me? We have lost the connection. Hello? Hello, Jyoti? Hello? Hello? Jyoti, sir has lost the connection. Please connect him. Please keep him in the presented mode. Hello, Jyoti? Jyoti?
Madam, I can hear you.
Yes, sir. Yes, sir.
Yes. I think so. Your doubt I was referring when we have the auditory system and I mean this sensory and motor organs in our body. See,
Actually, we'll
normally,
expect the signal from the brain, no, sir.
madam.
Actually, we'll acquire the signals from the brain.
Yes.
The input signals are from the brain, no.
Yes.
So, is it applicable for the deaf and dumb or not?
No, definitely when we say, madam, certain application where you want the signals which require connection from those sensory channels. Like I'm saying something, he is following that. At the time, I want to get his brain signals. He cannot because he has some these issues where he cannot listen what I'm saying. So obviously those signals is of no use because the brain signals does not correspond to that particular behavior. So other cases you can always do the integration of this brain signal to the speech applications like
If that person is really able to understand what we are able to communicate, then the reflections will be there. Then we can
yes,
capture.
yes. Even if when you are blinking your eyes also we can see a particular spike in your brain signals.
Yeah, even emotions also we can capture it.
Yes, madam. Actually, unfortunately, it is an online session. Other I would have given a demo. Like one of the brain signals I can take. I can show a demo. Even when you are blinking eyes, also we can see a clear variation in the brain signals.
Next time,
But
we'll
but 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 it depends on what, madam. Now, which channels? As I mentioned, brain hardware is more than 260 channels. So when we say facial expression, blinking, facing, I mean smiling, crying, those I have to take from frontal lobes of the human brain. Brain has four lobes, either in left and right hemispheres, right? So how we are going to take FP1, FP2 channels we are going to take just to see the better. I mean demo. At the same time, if you want to have a specific application like you mentioned, some deaf and dumb people to understand them, for the different channel we have to take.
yes. For blind person, if it is a blind person.
Madam?
Blind person, sir. If it is a blind person.
Ah. No, brain signals, there is no such difference blind or the only thing is now when we say someone is blind for a specific application I'm making, whether how is his mental state analysis, his brain signals are very normal like others. In fact, there is a saying somebody who is blind, their brains are more sharp.
Yeah, yeah. Then we can capture more effectively, I think, from the
Yes.
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 But he
Now,
is more smart.
see the currently most of the research with respect to this EEG, EMG is going on for lie detection, prosthetic devices, human contemplation, mental state analysis, and Parkinson's disease, and then this meditation, yoga, this influence of yoga, meditation on Parkinson's, all those things. And similarly, prosthetic devices, like I mentioned that who lost their limb in some accident, we can have a robotic arm type this one device where he can have a better controllable prosthetic device. Our practical session will make you more understand, but actually that's
Yeah,
no problem.
we'll arrange the practical sessions with the offline mode.
Yes, sure. Next time.
So I think participants, if you have any types of doubts, clarifications, queries, please interact.
See, I think we started with definition and motivation to virtual reality, and we compared with augmented reality. Then we also talked about this distributed virtual reality. Then augmented VR system, desktop VR system, or non-immersive VR systems. And then we have seen this tracking, viewpoint detection, and then cave model, many plenty of things, and so many applications we have seen. And then we have taken a case study on PC and some connected to VR applications and so many topics we talked about. Anywhere you have any doubts, you let me.
So anyone participants, please, if you are having any type of doubts, please raise your hand so that we can unmute you. I think no one is having any type of doubts, clarification, queries, sir.
No problem. That's fine. So then what I will do, I'll share my email ID. If you have any other doubts, you can always go in
Thank you very much, sir, for your valuable time as well as your excellent presentation regarding the virtual reality and augmented reality.
Thank you,
We
madam.
will,
I just posted my email ID and phone number.
yeah,
So
this is
when
a
you have
new
doubts,
area where we don't have much knowledge about it, but you have given insights about the virtual reality so that we can apply in our research also.
If you want, you can share at your perspective.
Jyoti, Jyoti, yeah, propose vote of thanks.
Thank you, sir, for your input and knowledgeable session on the area of reality and augmented reality. I think our participants have gained a lot of knowledge about this session. Thank you, Anurag. Shall I?
I think there is some problem, madam. I think we are unable to hear. Yes.
Thank you very much, sir. Thank you very
No,
much.
no problem. I think we can close it. We have done it now. Thank you very
Yes.
much.
Thank you, sir. You can close the session. Thank you very much.
Hello. Dear participants, thank you so much for your active participation. I will share the feedback link and quiz today's session through WhatsApp chat only. Thank you so much, Anurag. Ma'am, shall I close?
I'm going to stop streaming. Mm.